Electronic configuration. So let's look at the terms. Remember, if electronic configuration, you cannot use 2.8.812. Okay, you must use the SPDF notation. Okay, so for 30 means it is a D block element. So you can write must start from 1s2, and then you can end with 4s2, 3d10, or 3d10, 4s2. Okay. Now, remember you must fill in 4S first, then followed by 3D. Okay, then now next one is students tends to like to write comma. Okay, you cannot write comma. It is incorrect. There is no comma when you write SPDF notation. Next term is orbital diagram. Orbital diagram, remember you must draw the box. Okay, it's easier, and then between the box there is spacing. You can also use without the box, but you have to be very careful because of the spacing must be very obvious. Okay, now I want to highlight is the arrow. The arrow is half-headed arrow, not full-headed arrow. Then let's look at the prior knowledge that we have. Okay, this is 2.5, which you have learned before. Now we use the SPDF notation. And remember to apply the rules. You can use upward or downward. Okay, either one is correct. However, if you didn't follow the rules, okay, for example, you can see that there are different directions before you fully fill, then it's wrong, and then pair up first before simply fill all the orbital is also incorrect. Okay, next one. Okay, as you can see here, it didn't obey Hans rule. Okay, so remember must singly fill first before pair up. Now this part I would like to highlight on cation. Okay, if you see 2 positive means there are electron less than the proton number. Okay, so when removing electron, we start from the highest principal quantum number. Means we take away 4s2 first, starting from 4s orbital, not from 3D. Next one is terms. Look at terms. Electronic configuration, we will use SPDF. Okay, most stable ions means we are looking for octet. Okay, so if we see here, this is 5 electron only. So this one will become 8 valence electron. So 8 valence electron, we know it is stable, so it is octet. So the most stable ion is B3 negative. Okay, quantum number D. Okay, let's look at D first. Okay, quantum number, remember it is N, L, M, S. Okay, then for the 13 and 14 electron in P atom. Okay, so here I have labeled, okay, as you can see here, I have labeled the electron, how to fill in them, and then write the NL, MS. Okay, 13 and 14. You can write any combination of the two. But remember, if you want to write the combination of two, you must choose the same spin. Okay, if it's clockwise, you choose positive. If anti-clockwise, you choose negative. Because when we fill in, we cannot put in negative, anti-clockwise, then clockwise. It is incorrect. Okay. Now, next question is, state the number of electrons when m equals to 0. Okay, so when m equals to 0, as we know, when L equals to 0, m equals to 0. Okay, so this one we have 0, 0. And then another one, when L equals to 1, m can also be negative 1, 0, positive 1. So we also have 0 here as well. Okay, then you calculate all the electron, the answer will be 9. Okay, last one is valence electron. Okay, valence electron, we look for the outermost. Okay, so prior knowledge 2.8.5, 5 will be the valence electron. So now we use SPDF, so 3s2, 3p3 because 3 is the highest principal quantum number. Okay, just want to highlight one thing here. Okay, if let's say we are looking at D block element, if it's D block element means that the valence electron is 3d and 4s. Okay, remember 3d and 4s. Okay, summary. Electronic configuration, you must know how to write for neutral, cation, and anion, especially for D block. Okay, for D block, we always fill in 4s, then only 3d. But when you want to remove, you remove 4s, then 3d. And remember, don't write 2.8.8 anymore. Okay, and then cannot write comma in between. For orbital diagram, remember the half-headed arrow. And then you are asked to give number of electrons. Look for NLMS. What is the meaning of each of it? Then quantum number must always refer to NLMS. Okay, another one is the term shape of orbital. Okay, if you are asked to draw the shape of orbital, especially for 3D, the easiest would always be 3D z square and 3D x square y square. Okay, so that's all for this part.